Okay, good morning, everybody, or good afternoon, or good evening, wherever you might be. Thank you for joining this second webinar involving ourselves, Cruse and Roland. For the next hour, we'd like to show you a really neat end-to-end solution for scanning, editing, and printing. Today we're dealing with mostly decor designs, but the technology can be used for 2D scanning and ceramics, even textiles, wall coverings. So if you're dealing with structure and 3D, this would be an ideal moment for you to close the door and watch the webinar for the next hour. Questions, of course, please fire questions at us. We have 5 panelists in here at the moment, but we have other people in the background ready to answer your questions. So feel free to answer questions via the Q&A, and also there is a chat. The chat system, you can direct questions to individuals or to all the panelists, and likewise with the Q&A. So without further ado, I'm going to introduce Martin from Cruse, who's going to show how the wonderful Cruse technology enables you to scan 2D and 3D large format documents and artworks. Over to you, Martin. Oh, I'll start with you, Jens. Sorry. Jens, are you starting?
Yes, I just need the help of Martin to switch.
Okay.
Okay. Well, hello to everybody. For those who don't know me, my name is Jens Becker. I'm the CEO from Cruse, and I will just introducing Cruse a bit and then pass over to Martin, who is the Business Unit 1 manager and does all the technical things. Thank you for joining us and being here at that time. And yeah, Martin, let's go on with the next slide, and let me talk a bit about Cruse. Cruse, a mid-sized company in Germany. We have around 26 employees. We build, manufacture 2 scanners, customized scanners, since 1979. So we have a lot of experience, and we are proud that we call us like a manufacturer. 95% of everything which is being produced at Cruse is being customized and developed in our house, in our place. So we have Martin, can you? We have already sold around 800 scanners worldwide. Our biggest target group is actually the decor industry and the service providers, followed by the museums, archives, and the fine art reproductions. As you can imagine, the decor industry can be splittered and categorized in many groups, like tiles, wallpaper, flooring, and we are strongly, especially in the decor, we have around 60 to 65% of our turnover comes from the decor industry and the service providers. We have 3 showrooms. We have one in China. We have one, of course, in the headquarters in area of Bonn, Wachtberg, and we have a showroom in Houston, USA. As I mentioned, customized is our job. We have a construction department, we have a software department, we even do the coatings of the scanners, we melt, we drill the steel, so everything what we give to our customers, we know from the scratch. Okay, we have several scanner types. I will not just fly over them. We have our, let's say, our biggest scanner within the portfolio, the scanner 4.0 synchron table. We have a portal scanner, which can scan 3 meters 60 times 2 meter 50, and can work with 600 dpi or 1200 dpi with a telecentric lens. and which Martin will talk about very soon, we have new in our portfolio a small scanner. So what you can see is we have all types of scanners which can be perfectly fitted to all your needs. We don't have a system you need to buy everything. We have a modular system. What option you need, you can purchase. And you can be sure our scanners are very, very reliable. We have customers since 2002, 2005 with the synchron tables. And whenever there's an upgrade, there's no need to buy a new scanner. You just upgrade your old scanner. Of course, that doesn't work with every scanner, like here, the ST, the small scanner. There will be upgrades, but this is then, of course, limited. Our base scanner is a synchron table. If we get a new camera system or a new LED system, you never have to buy a Cruse again. You can always work with the same platform, which I think is also unique in the market. As unique as the variable reproduction angle, we are the only one in the world who scan at an angle. Why is that important? Well, actually, if you take a look at the floor, you never look straight down. You always look from the side. And therefore, for us, it's also very important that our customers have this possibility. Besides, it gives you some very high quality steps or advantages, especially when it comes to 3D, which is called hybrid. So take and listen to Martin, and thank you again for being with us, and thank you for AVA for organizing everything, and then Roland for completing the workflow, which I think is the best you can get. So Martin, take on.
Okay, 1 second, I need to change my screen. Okay, we want to see this one.
Just so everyone's benefit, this webinar will be recorded again and made available to you.
So, hopefully you can hear me and see my screen now. Oh no, you see the wrong screen. So 1 second. We want to share this one. So now, can you see the scanner and our software?
Yes.
Okay, perfect. Okay, so I want to show you.
Sorry, Martin.
Yes.
Sorry, just a quick pause. Just for everyone's benefit, the Zoom software tends to put the panelists' faces down the right-hand side of your screen. If you're able to move those over somewhere else, either to the top or the bottom, it will also help Martin's presentation and the following 2 presentations. Thanks, Martin.
Okay, thank you, Duncan. Okay, what I will show you is this. You see on the right our new small table scanner, which I will show you now live how to scan a 3D sample. And on the left is our scan software, or our Cruse Design Studio. Cruse Design Studio actually implements a lot of small or of different applications you need for scanning, you need for organizing your projects, and for post-processing of the scans. So this is, for example, the factory software, which is calculating the 3D information from the scans. So what I will do now is I will start a project and show you how simple we can scan something. So I will just tell it test. So I give a name here, and then I can open this template manager, or this template selection, and here I have predefined templates. And what I will do now is I will scan it in 3D, and I will also get a gloss layer, which Rachel can now later use in AVA to prepare the other work. So this here you see now the all settings I need to do for all settings I need for a 3D surface scan, including gloss, will be predefined. So I just need to confirm this, and then our scan software is loading. What I already did here on the right side, you can see I put the original on the table, and I moved to 7 centimeters because it's pretty thick. So the lights are already on the correct position, and then I can do a pre-scan first to select the scan frame I want to scan. So this is our new scanner here. You can see we have very very intensive or high power LED lights. We have a fixed resolution, so lights and camera will move up to the sharpness area or to the original height I selected or I put in. And now you can see that it's moving pretty fast. So this is the original we want to work with today, and which is also then later edited and printed from AVA and Roland. So I will select the scan frame here. And then simply I need to start a group scan for the photometric stereo calculation we are using here to get the 3D information. I need actually 4 different light directions, which are done by this light angle device modes and right light angle device reverse and normal one. So I get 4 different light directions here, which is necessary to get the 3D information. And also what we are doing is we scan it in a gloss mode to get the gloss information or gloss mask as well. So I start the scan. So those who know already Cruse scanner, you know we have this light angle device, which is normally slide on the lights, and on this scanner we have this lens plates which are doing the same job. So they are directing the light in 45 degrees to the original, and then we get this already looking 3-dimensional image here. So now this first scan is starting, and we see here each scan needs 23 seconds to finish. While the scan is running, I can tell you a little bit more about this software. So we have here a project explorer, which is helping us to organize and to projects and to give them names, to organize them in folders. So and which also have a it's like a small project database. Also, what we can do is we can share the jobs between workstations. So if we have one scan workstation where the scans are done, when we can automatically send the projects to another workstation where then the 3D calculation is done, or where maybe the designer is and select which type of result he want to export and he want to work with. Then we have here, this button is image stacking. This is actually to mix 2.5D scans together. So the difference between 2.5D and 3D scans is with 3D we get a grayscale image as a result, which shows us the height information. I'll show you later. And 2D scans with a 3D effect means that we generate shadows by directing the light or by only switch on one light. And then when a shadow is created, it looks already 3-dimensional, like what you see here. So now the second scan is done, and I need to rotate now our light angle plates. The software guides us through this. So you see here, there comes a message, I have to rotate them, and what I will do now, 1 second.
It's good to say it's not a recording, you're doing this live, Martin.
Okay, so this was all to change the light to the next 2 light directions. Now the third and the fourth scan is starting, and then, as I said, we have this gloss scan, which also needs some 2 different plates, which are directing the light in a way to the original that we get reflections or gloss effects, and this is what we can use later for generating the gloss mask. What we also have here in the software is this template manager, and there you can add or you can change this predefined settings I selected before at the beginning, where I selected 3D surface scan including gloss. Here you can add them, you can change the settings you want to have, you can already predefine the scan area you want to use. So this is everything is possible using this scan here. And what we also have is we have this profile scan or Cruse profiling software. With this part, you can calibrate or you can generate color profiles for your printer. So this is generating color charts or targets, and then we can print it and scan it with the Cruse scanner, and you don't need an Photomat or an i1 or something like this to measure the target and to generate a printer profile. So, but who wants to have some more information about this, please contact me. I will explain you.
Yes, good point, Martin. The I mean, certainly the AVA software utilizes ICC profiles, but when the scan's passed over to Rachel next, we can talk a little bit about color management and predicting the output of the design.
Okay, I need to change the plates again. 1 second.
Okay. Yeah, so if you've got any questions about the Cruse scanner, please feel free to ask via the chat or the Q&A, and the team will answer those. As Jens explained at the beginning, Cruse have a number of wider format scanners available. This is the new mini scanner that they've recently developed.
Yes, correct. And completely new is that this scanner supports as well gloss modes or gloss detection. So for this, we have this special designed lens plates of which directs now the light to the original. And you can see here the glossy parts on this original will, like this part here, will be a little bit brighter because the light is reflecting from this part then to the sensor, to the CCD or to the CMOS sensor, which we are using here. And this helps us then to generate or to calculate the gloss map and the gloss information of the surface. So now automatically the design studio hands over this scan job or the scan batch, which includes the five different scans, to our factory software. And the factory software now is aligning the images and then using the photometric stereo technique to calculate the real depth information from the surface. So the aligning needs a few seconds. So we have implemented really a few different apps here, and the framework, the design studio is managing the whole workflow between those apps. So here you see already a first preview of the result, which is done in false color. You can also switch to grayscale by just clicking on this bar here, and this is what I think is normally used in the industry. So, but what you see also is I can zoom in, and it's pretty unsharp now because it's only a preview. So before I start the preview, we have here this flatness parameters, where I can select the flatness. So this means I can, if I don't want to have this huge height differences, you can see here, because when I want to print it or I want to use it for design or for a press plate, I normally need it in a flatter way. So what we can here do is we can prepare that it's more or reduce the size to a lower value without losing the details. So I will start the process, and while the calculation is running, you can see here with the red bar, the software stays fully usable. So you can, if you zoom in, you will see it's getting more details, so it's not so unsharp anymore. But you can also then do everything else in the software already. So what we else get beside this grayscale image is this diffuse color image, which is a color image without any gloss or reflection effects on it. So our shadows are also removed. So this is also calculated from the software, so it's getting also more sharp or get more details. Just now it's only a preview. And this image is important. It's called also albedo image in the 3D world. And this image is important if you want to use a color channel on top of a 3D print, like Stefan from Roland will do it later. Then you need some color information without any shadows, because you will build up the shadows, or you will build up the height, and you don't want to have shadows inside, which will look not nice then. So for this, we need an image which have no shadows or reflection or gloss on it. Then we have this gloss result. So here you can see the one part of this original have more gloss, which it looks is more white is more gloss, and more black is less gloss effect. And this is also calculated from the image.
I think it's important to point out, Martin, I mean, on my screen that looks fantastic, but I think it's a given that the quality on your screen is very sharp, and the Zoom software is making compromises in all our displays to give it a fluid feel. It's worth pointing out to the audience that the quality is even higher on a static computer.
It's not looking sharp?
No, it is. It's looking great, but I know from experience that what you're looking at is even higher quality than what we're looking at because of the Zoom application.
Okay, thanks, Duncan. You see here already it's green. So what we have already done the whole process. So we can now already export the images, but I want to show you a little bit more of the software. So here I can change the histogram of the grayscale to don't have the unused parts in my image. And then we have this shaded view, which is using the 3D information and the color information and generates virtually a new image. So here I can, and using this, I'm able really to zoom in. I don't have to select the value. I can really go through the image interactively here. And you see here this part, and there I can change the lighting. So I can change the position of the light to the original, which would also changes the direction of the side where the color or where the shadows appears. Of course, I can switch off the color channel to make sometimes then you can have a better view on it. And also we have this gloss feature here, which will use the gloss layer to add the gloss on also here in this view, and then you can see here already it's a little bit glossy. What I will do is I will switch off the depth. You can see it much better. And we can change the material roughness. So this means, as lower the material roughness is, as then we have something like a spotlight. So the gloss effect is only appearing on the area where the light is really on. So, but if I go higher with the material roughness, it's getting over the whole original. So what else we can do? Okay, I will switch on the color layer again. So here you can really virtually recreate everything all lighting directions. You can control the gloss, you can control material roughness, you can control the depth, and I can even get more than we also increase the depth, you can see. And what else I can do is I can add lightnings. So now I have 2 lights, and then I can independently control the effect from each lighting. So I can switch off the gloss effect from one light. I can increase it from the other light. So I can really then generate new images or new designs, new looks, just by using the 3D, the gloss, and the color information. Okay, so now to hand over this to Rachel, I need to export it.
That's fantastic, Martin. Thank you.
Thanks. So, and yeah, the exported file, I will save the files here as a project, and Rachel can open then the project directly in the AVA software.
Yeah. Okay, that's wonderful. Thank you, Martin. That's a really good demo. So we'll just give Rachel a moment to take control of the screen, and I'll introduce Rachel and explain what she's going to show you. So all that critical information is now going to be imported natively into AVA. So a couple of years ago, we started developing our first 3D tool. And last year, we developed the native interface for the Cruse scan data, which is a crisp data format, and that holds the high quality RGB scan. It holds the height map and the glossy areas, which Martin has explained and shown in the demo. So the Cruse software comes with very nice visualization and lighting tool software and other tools. Now, the difference, what Rachel's going to do, Rachel's actually going to manipulate the data. So for those of you who work with repeating patterns, you will know that this design is not in repeat. So what Rachel, I mean, I don't want to steal Rachel's thunder, but she's going to show you some very nice 2D, 3D simultaneous editing tools in order to make this design a repeating pattern, maybe a different scale. She can change the design as well. So she's going to get the design ready to pass to Stefan's technology for printing, for rapid prototyping. So are you ready, Rach?
I am. Can you hear me and can you see my screen okay?
I can.
Yeah, brilliant. Okay, thanks, Duncan. Thank you, Martin. That was great. So as you can see here, I've got the scan that Martin created, and we have the grayscale, the height, the gloss, and the image here, and all of that native data is imported into AVA on literally file open. We just take all the data in. So the first thing I want to do really is like Duncan said, I want to create a repeating pattern from this document. So I'm going to use my carbon copy tool. I'm going to crop out a section. I'm going to use the carbon copy tool to fix the edges. So I'm just going to take a crop first, like so. And I'm going to take this to a new document. And I'll just put both side by side. So on my left, we have the original document with the crop tool, the crop box in. And on my right, we have the cropped area. So I'm now going to use my repeat inspector here to put this into repeat. And I'm going to frame that first repeat so that it's really obvious for me. So here's my repeat, but if I zoom into that, we'll notice that it doesn't quite repeat because I've just cropped out an area. So I'm going to fix that now. So I'm going to use my carbon copy tool. Now, if you're familiar with the Adobe suite, you will know that the carbon copy uses like relative and fixed in the same modes. So we have all of that, but we also have this crop box source. So instead of using a cursor point as a source, we're using the crop box. So when I option click in here, I can start copying into the new documents. And because I'm copying directly from the original scan, I can make that repeat join instantly disappear. So hopefully you can see what I'm trying to explain. What's happening here. And I'm not going to spend too long on this because we do have a time limit, but you can see how quickly this tool can put a scanned document into repeat.
Looks good, Rachel. There are other repeating techniques. Some people like to copy paste over the repeat join. This is a very rapid tool. You also do contour repeats, which are also called jigsaw repeats, where you can have a contour edge and overlap the edges together, wrap around repeating, for example. And we've also got, for anyone in the wall coverings industry who are watching, we also have contact repeats, where the second repeat is a 180-degree rotation from the original, which you can also put in repeat. And of course, mirrored repeats. We have mirrored repeats as well.
So that's my document pretty much in repeat. If I had a bit more time, I would take a little bit longer over that, but hopefully you can see that tool working. So I'm now going to just drop that back down to one repeat, and I'm going to close the original scan because I'm now done with that. Now, just one thing that I want to point out before I close these documents was when I was using the carbon copy tool there, I had all three of my layers active. So I was carbon copying the depth, the gloss content, and the original image at the same time. So you don't have to do each layer independently, just do it all in one go. So I'm just going to close down the original scan now, make this half the screen. So what I want to do now really is, now that I've got it into repeat, I want to have a quick look at how this is looking in 3D. So I open my 3D structure simulation window, and we can see in here what it's starting to look like. And importantly, I can view that in repeat as well. Okay, and I've got some default view angles set up here. So default view angles is just my preferred way of looking at the documents instantly when I open the design. So you can see that we can move this scan around and observe it. Okay, we can change the lighting. Do that. Change the lighting. And we can view the height without the image on top, like so. So we can start to evaluate areas that are going to cause us problems in production and start to fix them, okay? Now, before I do that, I want to look at this document under a production profile, so under the conditions in which it's going to be produced. So if I go down here in my little corner here, you can see that I've got some more settings that I can apply to this structure. So I've got a gloss intensity, the material roughness that Martin was talking about, and I've got an engraving curve here. Now over on my left-hand side, I've got some preset engraving curves. So I've got a chemical emboss here, so I can click that button and quickly view the engraving curve for it, the gloss intensity, the material roughness at my preferred viewing angle, which I can come in and change, okay? And I've also got, if I just open that back up, I've also got a laser engraving mode saved here too. And again, I can just change that. And down in the bottom corner here, you can see that I've saved my laser engraving with 200 microns. I can change this. I can just change that by using the slider bar, or I can type in here the number of microns that I'm going to engrave this at, okay? So I've got my engraving data in there, my production profile, if you like. Now I need to just start locating some faults that may cause me problems in production. So I'm going to come back over into my 2D view, and I want to look at the data, the height map, the depth map. I'm going to activate the depth and the gloss content, so I'm going to edit them both at the same time, okay? And I'm going to use this fault finder button here, that when I press it, it adds a bright red layer for me, and it creates a circle as my cursor. So hopefully you can see that on the left-hand side. And on my right-hand side, I have a relative cursor. So that means that I can work away. Let me just zoom out of here a little bit. And I can just start to identify areas that I'm not particularly happy with that I think may cause problems in production. So that's now put a little red circle on the area that I want to fix in my 2D view. I can also view the circle if I need to in the 3D view. And I'm going to use a range of tools really to edit this data, and we'll see the changes in real time occur in the 3D view. So let me just zoom right in to one of these areas. Oops, there we go. So that's going to zoom right in for me. And then I can just zoom in here, and this is because of my relative cursor, I know the little patch that I want to edit. So for example, I can make a selection, and I can take that selection and put it there. Okay, now that would work if I activated the correct layers, so bear with me. So I'll just do that again. Activate the height map and the gloss, and you can see that I've forgotten to copy and paste. So in the 3D view, the pixels have disappeared. So now I've got this flat area. There's no content there at all. So I'm going to undo that. And I'm going to be a lot more careful this time to copy and paste the data over like so. And I can flip that selection, okay? I can use, for example, the carbon copy tool. So if I just select my carbon copy tool, but this time go on to relative modes, and again with my heights and gloss content available, I can go to somewhere else in the file, and I will change my tool so that I've got a perfectly round brush. Option click, say there. And then I can just come in here and start to edit that data. And you'll notice that the data, the pixels update straight away in 3D view, like so, okay? I can also use things like dodge and burn. So I can go to my dodge and burn tool, and I can make darker, so burn the dark areas in here. Now, just to explain that the AVA software uses black as its highest point and white as its lowest point. So if I want to increase the contrast of this area, I'm just going to turn that off. I can start to burn these areas here, burn the shadows actually, and you'll notice that this area starts to get higher and flatter. And then I can dodge, for example, the midtones and start to lighten those up. So they will now become lower, okay? So now I've got a very contrasted area there. Copy, paste, dodge and burn. Yeah, you can use any paint tools basically to edit these pixels. So then once I'm happy with the design in repeats, the structure is working well across my repeat joins, I can start to develop the structure further. So let me just go back to that. So I'm happy with that. So I'm just going to close that window for now, and I want to develop my design a little bit further now. So I'm going to look at it in one repeat, and I'm going to quickly separate this. Now I'm going to separate it for digital. AVA has a range of separation methods that can prepare a design for engraving, no problem. We've got lots of separation tools, but I'm going to use a very quick method which provides me with 3 channels that I can color very quickly. So just by pressing this button here, I now have 3 channels, and they just need a little bit of work. So I'm just going to change their curves just to make it look a little bit better. Okay, that'll do. So happy with that. And then what I'm going to do is I'm going to load in some colorways. So at the moment in the top right here, oops, sorry, I've already got some. Let's just get rid of those. So I've got one colorway, okay? So I'm going to go to the colorway menu now, and I'm going to load in some colorways. I'm going to add 5 more, so I end up with a total of 6, and then we'll see that I now have a range of colorways in here. So that's a little bit of further development that I've done to this document. What's nice about this is I can then go back into the structure simulation window, and I can view these colorways in here too. So again, let's just apply one of my profiles, zoom out a little bit, and I can flick through the colorways like so. So I'm getting really happy with this product now. So it's now time to present this to my colleagues to see what they think of this idea. So going back to my design, I'm going to present my ideas. So I'm just going to pop this back into repeat first of all. I want to show off my repeating tile. I'm going to go into my layout page. So this is essentially a presentation page. Let me just pop that into repeat. Sorry, needs a few more repeats just to fill that gap. There we go. So this is my presentation page, and on the left, I have my idea of a repeat, and then scattered around that, I've got my ideas for colorways, and then importantly, I've got the concept of what this would look like as a tangible product. Now that's really the only thing I'm missing here, is a tangible sample for people to feel and touch, to get an idea of what this is going to look like. So the next stage would be for me to print this and process this through what we call is a splitter. And what we do is we take the height map of this document, so the height map that was scanned by Martin, and we slice it into various layers, as many layers as we decide. And what that does is it prints a layer each on the Roland, which Stefan's going to show you. So I would process that through this, the splitter, choose how many layers I want. I'll put some white down, and Stefan will explain why we use white on this printer. And essentially, we end up with a document looking like this. Bear with me. Here. So this is essentially what we send to the printer. It's a layer. Each block here is a layer that would get printed. So I'm going to hand this over to Stefan.
Rachel, what about non-registering embosses?
Oh, yes, let me just show you that. So back to my...
So we've made this software very user-friendly for designers and designers who want to experiment with different structures. So maybe they want to, maybe they've got the main print design, but they want to experiment with different types of structures, maybe structures from the archive, maybe different structures scanned directly off the Cruse scanner. The software allows you to experiment with obviously enregistering embosses, but also non-enregistering embosses. And it's also technically possible to combine different embosses to create one unique new emboss. So structure design is a big part of what we've developed here.
Yes, sorry, I almost forgot to do that. So here's what I've done is I've loaded in an all over structure. So just to show you what that looks like. Okay. And then when I take that into my structure simulation window, this starts to happen. So we get a really nice feel for an all over structure. And you can combine that with an existing gloss layer, for example. So I can turn on the gloss, and then we will start to see that come through from the existing scan here. There we go. So that's really, really glossy now.
Yeah, it's changed the look completely, isn't it?
Yeah, completely. Obviously you can change, oops, that's a bit too much, but change your the height in microns and experiment with with that. And you've still got your colorways there.
So as Rachel's shown you, it is a creative tool. It's giving people the ability to experiment more with structures before they commission anything for engraving and manufacturing. You can fault find in this software, as Rachel mentioned earlier. It might be a fault that you just can't see in the 2D design. Even when you put the design in repeat, you still can't see it. But when you put it in repeat and put it into the simulation software, sometimes faults can arise, can be spotted, usually caused by reflective problems. Maybe there's no banding in the design, but certain light angles show a noticeable repeating banding error. So that can be highlighted and rectified using this. Yeah, like Rachel's shown you there. You probably spot that in the 2D, but I've seen other more subtle examples where you just can't see it in the 2D, but it all of a sudden it stands out when you look at it in 3D. So we think this is accelerating and promoting the whole embossing process. However, the final part of the presentation, which is very exciting, is Stefan Höf's Roland HAPTIC printer, where you can, in the comfort of your studio, you can print your own live 3D sample of your design. So I'll now use this opportunity to present Stefan from Roland. Hi, Stefan.
Hello, everybody. So I will just start my presentation. One moment.
Thank you, Stefan. I'll stop share now.
So, warm welcome to the audience, and thanks, Rachel. Yes, first thank you to the previous speaker for presenting their hard and software solutions that makes our life so much easier. I have to admit that I'm really happy about this partnership because wherever you find a Roland printer for this solution, the chance is very high that you ought to find a Cruse scanner. And with AVA, we have today the perfect connection between these both hardware devices. So my name is Stefan Höfs. I'm a business development manager at Roland DG. And what I want to show you today is how to bring all the digital data we have created so far back to reality. Because in the end, what you need to experience an object or a product is something you could hold in your hands and touch. Before we start with this, some words about Roland DG, just that you know who's talking to you. So Roland DG is one of the leading manufacturers of large format printers, founded during the first digital revolution in the year 1981 in Japan. Today, we have an installation base of more than 150,000 printers, and we are available in more than 200 countries with a net sales of about 340 million euros. Besides being one of the market leader in the sign industry, we also offer all kinds of dedicated print solutions for different industries. And one of these solutions I will show you today is the haptic proof. So let's go into detail. To understand the solution, it's important to understand how digital inkjet printing is working. In our case, this is very easy. We just have a table moving from the back to the front. And at the same time, we have a print head moving from the left to the right, from the left to the right, and spitting at the same time ink on whatever object you have placed on the table. The ink we are using for this purpose is a so-called UV ink. This ink is curing when exposed to UV light, and that's why we have placed a UV lamp to the left and to the right of the printhead. And the good thing with this ink, that's what we need for our application, is that with the UV ink you are able to print very thick layers of ink, and this is needed to build up the tactile or haptic structure on your object. The colors that are available are CMYK to print the color information. That's pretty much the same as with your inkjet printer you probably have at home on your desk. But besides this, we also have a gloss and a white ink. The gloss ink we use to build up the haptic structure. With the gloss ink, we can print ink layers between 30 and 60 microns per layer we print, and we can print multiple layers to build up higher structures. And there's another interesting thing with the gloss ink. Normally we use the gloss ink as a matte ink. That means the UV lamp is directly placed beside the print head. We do this when we build up the structures. But you are also able to move the UV lamp a little bit to the back so that there is some time between printing the gloss ink and curing it. And thus we can produce different gloss effects. So we can use it not only as a matte ink, but also as a gloss ink to produce gloss effects on our haptic proof. Last but not least, we have a white ink. The white ink is important because you will, in our case, the white ink is important because you will see after building up the haptic surface with the gloss ink that the gloss ink is a little bit yellowish, and we need then first a layer of white ink just to make the CMYK colors more bright and correct. So that's all to the technology. Before I will show you a short video that makes everything more clear, let's again review a little bit the pre-press process. So we started with the scan from Cruse, which delivers us most important two outputs. One is the grayscale image that presents the height profile of the scanned surface. White is presenting the height 0, and black is presenting the maximum height. And on the other side, we have the high resolution RGB image that represents all the color information we need. So after the scan process, you use AVA to do all the manipulation of the image data, like making an endless pattern to have a repeating image afterwards, and all the other manipulations you have to do. But the good thing, AVA can also send directly the print job to our printer, and they are able to slice the height profile to be able to print with the printer the mountain really from the bottom to the top. If you want to have a one-to-one copy of your original material, what is also important is to know the maximum height difference within the surface of your object. And you just then have to divide the maximum height through the thickness of one layer, which you know, and then you know how many layers you have to build. So that's all. The pre-press process is done. You just press on print in the AVA software, and then the printer starts printing. And I will show you the video now. In real time, and what you see for the moment is real time. The whole process will take in this case, more or less exactly 1 hour. We print 9 layers of varnish, each with a thickness of 60 microns. And then we print each layer took about 6 minutes. And then we print 1 layer of white and 1 layer of CMYK for the color information. And the white and the color information each took 3 minutes. So in this video, I use a lot fast forward so that the complete length of the video is only about 3 minutes. This is the first layer of gloss varnish, and you already see that it is a little bit yellowish. The next 2 layers will be the 5th and the 9th layer, but in reality it's really 9 layers of gloss ink to build up the structure. And then you have the white layer and the CMYK layer. 1 hour seems a lot of time, but I will shortly tell you a little bit about the beginning of the solution. It's already 8 years ago, and one of our customers asked us to print a proof of a structured wallpaper, size 70 centimeters to 1 meter, and a height of 1 millimeter. We managed this, and we were really proud about the results, as well with the structure as also with the colors. And we showed it to the customer, and the customer was also very happy. And at that time, we were not used to such long printing times. And when the customer asked us, how long have you printed on this? We looked a little bit ashamed to the floor and told him 8 hours. But the reaction of the customer was, what? Only 8 hours? We normally have to wait weeks before we get a 3D sample of our products. And at that time, we realized that we have found a proofing solution for all the people creating 3-dimensional haptic decorative surfaces. Now the print is finished. You see the last CMYK layer. And at the end, we will see a little bit close-up of the structure. And to really experience this, you need a real sample and have to touch it and to look at the structure, because this is just an image, and yeah, you need to touch it to get really the quality of these prints. So I've talked a little bit about the beginning of this solution. Today it's an established technology. So when we started with the solution, we were first successful in the wallpaper industry with structured wallpapers, but shortly after that, the flooring industry was following. And today we have also some installations in the automobile industry. What they are doing, they're mainly proofing the artificial leather optic in the car cockpit. There are also other applications for the 3D print, like museums and art reproduction. But when I talk about the proofing solution, it's really mainly for the decor industry. So how are they using it? They're using it on the one side for the design process. That's what we have seen today. Very often sample books were only created digital, and the tools for mass production then were only made when an order came in. And the other purpose where our customers are using this is as a real proof process. So to send them a proof with the final data for the mass production. And sometimes people are only using the haptic print, and then they use it as a press plate to apply it to the original medium and the original print, what makes the proof even more realistic. The advantage for our customer is that they are very flexible. They can react very fast on customer requests. If a customer wants a change, if he complains about the design and wants small changes, you can realize this very fast. You don't have to give your sensible data to third-party companies, what you maybe have done in the past and what is always a problem for a lot of companies. And it's very cost-effective compared to the analog way to produce samples. So I'm nearly at the end, but at last I wanted to show you a little bit our printer portfolio for this application. So we have flatbed printers in different sizes, starting from a width of 50 centimeter up to a width of 1 meter and 60. Lengths could be up to 3 meters or even more. Special thing with these UV flatbed printers is that they are using fine art printers. This is the difference to other printers because they are not made for high production, but to achieve the resolution you need for this application. And another unique thing is that these printers are completely integrated in the workflow together with Cruse and AVA. If you want to know more about it, so I will not go into detail here. And if you are interested in the solution, please contact us. So thank you very much for listening.
Thanks, Stefan. That's really good. Thank you very much. Just to add some more technical detail about your printer, we can selectively place the gloss, can't we? We've had customers ask us to put the gloss at the shallowest part of the design, or vice versa, at the highest part of the design. We can do that. So it doesn't have to be an all over gloss, does it?
Yeah, that's true. You need to separate 5 to apply the varnish at the gloss ink. And this is really useful to have partial gloss effects on your print.
Yeah. And we have one of the compact scanners in our studio, and we love it. It's great for quick samples. And I know Stefan mentioned an hour, but that's still relatively quick. With the large Cruse scanners, you can actually scan a large artwork, edit it, and proof it at a 1-to-1 scale on the widest Roland HAPTIC printer as well, can't we?
Yeah, that's possible. What you need additionally, and Martin, I don't know if you can get this out of your scanners, is you need the information about the maximum height so that you then know how many layers you have to print. And if you have this additional information about the maximum height within in the structure, you can do a 1-to-1 proof of the structure.
Yes, it's stored in the meta or in the TIFF text. There is the full height range stored, so that we capture it and we save it.
Right. Okay, so if anyone has any questions, now's a good time to ask on the chat or the Q&A. If not, these are our contact details. We can definitely answer all your questions, but obviously we can also run a personalized demo for you at a later stage if you wish, using your designs or just having an exclusive internet demo of the technology. Well, that draws to a close. Thank you, first of all, to the attendees. Thank you so much for your time and attention today. And thank you again to the panelists for making this ambitious webinar look so easy. That was really good, very enjoyable. The time has just flown. Okay, so I will sign off now, and thank you very much. Very much appreciate it.
Thank you.
Thank you.
Thank you. Bye-bye.